Question number 4. Which of the following is an example of a function whose graph in the xy plane has no x-intercept, no intersection with the x-axis? No x-intercept means no intersection with the x-axis. A linear function means a straight line. A linear function whose rate of change means the slope, is not zero. I remind you again about the linear equation. I said before, if we have linear equation like this, our slope will be positive. The slope will be positive. And if we have the line like this, the slope will be negative. M will be negative. And in these two cases, if we extend the line, if you extend the line, it will intersect the x-axis. And the same for this one. It will intersect. But if we have inclined line in the linear equation, if m is not equal 0, positive or negative, the line will intersect the x-axis. It means we have x-intercept. Either positive or negative, the line will intersect the x-axis. It means we have x-intercept. But if we have line, horizontal line like this, horizontal line, m equals 0, horizontal line like this. And if we extend the line, do we have any x-intercept? No, because they are parallel. So in this case, there is no x-intercept, no x-intercept. Okay, so for this line, for this a linear function whose rate of change is not 0, it means we have, in this case, we have x-intercept. And we have x-intercept. As we said, if m is positive or negative, we have x-intercept. But if m is 0, we don't have x-intercept. So this answer is wrong, because be careful. In the question, you are asked to find the graph with no x-intercept. You are asked for no x-intercept. So the first answer is incorrect. What about a quadratic function with real 0? The quadratic function has 3 cases. Let me explain in more detail for this one. If we have a quadratic function, it has 3 cases. Maybe the curve will be like this. The curve will touch the x-axis. Touch the x-axis in only one point. Look at this point. This is called x-intercept. But we have only one point. X-intercept only in one point. So we have one solution. One solution in this case. But if we have the parabola like this, you can see now we have 2 x-intercept, 1 and 2. In this case, we have two solution. But if we have line parabola like this, there is no x-intercept. There is no x-intercept, and we say now there is no real solution. We have imaginary solution, but we don't have any real solution. So the parabola has 3 cases. Maybe one solution, case number 1, one solution if the parabola is touching the x-axis. We have 2 solutions if the parabola intersect the x-axis in 2 points, as you can see. We don't have any real solution if the parabola is outside or like this, or maybe downward like this. In these 2 cases, we don't have any intersection with the x-axis. So it's no real solution. So if now we return to our question, a quadratic function with real 0, yes, it has intersection with the x-axis. It has, look at the first and the second case, it has 1 intersection and 2 intersection. But again, remember, you are asked to what? No x intercept. This has also, it has intercept also. So this is not correct in this question. A quadratic function with no real zero. Yes, this is our case now. Look at this curve. It doesn't have any intersection. So this is your correct answer now. Of course, the last question is also incorrect because if I need to graph a cubic polynomial, the cubic polynomial may be like this. Look at this one. How many intersection? 1, 2, 3. Or maybe the trinomial will be like this. So at least we have one solution. Yani maybe we have one real solution, or maybe we have 3 real solution.